5.3, Solving Systems of Linear Equations by Elimination. Step 1. Multiply, if necessary, one or both equations by a constant so at least one pair of like terms has the same or opposite coefficients. And for our purposes, we're going to go with opposite coefficients. Step 2. Add or subtract the equations to eliminate one of the variables, and we are going to get rid of subtract. We are going to add. Step 3. Solve the resulting equation, and then step 4, substitute the value from step 3 into one of the original equations and solve for the other variable. Example 1. Solve each system by elimination. Check your solution. Letter A, this is our system. Now, if you take a look at your initial setup, notice that you kind of stack the equations, and then notice that the x is above the x, the y is above the y, the equal is above the equal, and the constant is above the constant. That's what we want. The next thing we're looking for is we're looking for two of our coefficients to have opposites. What I mean by that is if you look at your x and your x, do you notice that this one has a 3 and this one has a -3? They're opposites. That's what we want. So as long as this is already happening, we're good to go. If you look at your y and your y, this one has a 2, this one has a 4. Those definitely are not opposites, but that's okay because it only has to happen with one of our variables. So because that's true, we're going to draw a line and we're going to add our equations together. When you take a 3x and you add it to a -3x, that makes 0x, and those cancel, which is what we wanted. Then we're going to add 2y plus 4y, which is 6y. You're going to drop your equal sign, and then 7 plus 5 is 12. At this point in time, you just solve the equation. So now I'm going to divide both sides by 6, which is going to give me y equals 2. Now at this point, I have to take the 2 and I have to substitute it back in to one of these equations in order to find the x value. It does not matter which one you substitute back into, so I'm just going to choose to substitute it back into the first one. So I'm going to have 3x plus 2 times y, which is 2, equals 7. That's going to give me 3x plus 4 equals 7. Subtract 4. So 3x equals 3. And then divide by 3. So x equals 1. And then final answer, we're going to write it as an ordered pair, 1, 2. Remember the x always goes first, and that is the point on the graph where these two lines would intersect. Now for our first example here, it does say check your solution, so we're going to check this and make sure it works. In my first equation, we have our x, we have our y. We're going to substitute in 1, we're going to substitute in 2. So 3 times 1 plus 2 times 2 equals 7. 3 times 1 is 3 plus 4 equals 7. 3 plus 4 is 7, so that checks out. But remember, with a system, just checking one equation is not good enough. You have to check both. So now I'm going to check the bottom equation. We have -3 times x, which we said was 1, plus 4 times 2, hopefully equals 5. So -3 plus 8 equals 5, and that is true. So our solution is good. Letter B. -3x minus 5y equals -7, and -4x plus 5y equals 14. So first of all, x's are stacked above x's, y's are stacked above y's, equals are on top of each other, and then the constants. That's good. Now I'm going to take a look, and I'm going to look for an opposite coefficient. -3 and -4 are not opposite, but what about -5 and +5? That's good. That's what we're looking for, so we're ready to go. We draw a line, we add. -3x minus 4x is -7x. -5y plus 5y, those are opposites, they go to 0. Drop your equal sign. -7 plus 14 is 7. Divide both sides by -7. X equals -1. Then we have to take that and substitute it back in. Again, it doesn't matter where you put it. I'm just going to put it in the second one this time. Keep in mind this time we have an x, so -4 times x, which is -1, plus 5y equals 14. -4 times -1 is +4 plus 5y equals 14. Then I'm going to subtract 4. So we get 5y equals 10. Divide by 5. Y equals 2. And then final answer, xy, -1, 2. And again, that's the point on the graph where these two would intersect. Letter C. Okay, initial setup. X is sitting above y. That's not good. Our constant is above our constant. That's good. Our equal sign, that's good. But our y and our x are lined up. So if you remember the last two examples, remember the x kind of came first, and then the y, and then the constant? That's what we're going to try to go for here. So I'm going to take this first one, and I'm going to try to flip-flop my y and my -30. The first thing I'm going to do is I'm going to take my -30 and bring it to the other side. So I'm going to add 30. When I do that, I'm going to have 3x equals, because he's going to go away there, and then I'm going to have y plus 30. Then the next thing I need to do is I need to get my y over here with my x, so I'm going to subtract y, which is going to give me 3x minus y equals 30. And now I kind of have that equation figured out with my x first, my y second, and my constant last. Then I'm going to come to my second equation. I already have my y over here, but I kind of need to like flip-flop these. So the first thing I'm going to do is I'm going to add 6. 7y equals 3x plus 6. Then I'm going to subtract my 3x. I'm going to put the x first, so I'm going to put my minus 3x positive 7y equals 6. So now I kind of have that guy in the same order that I have this guy, the x and then the y and then the constant. Now I'm going to stack them. So I have 3x minus y equals 30, and I'm going to stack that with my negative 3x plus 7y equals 6. Now I have everything lined up. So I'm looking for an opposite coefficient. Well, on the x's, I have a 3 and a -3, which is what we want. So we're going to add. 3x plus -3x cancel and go to 0. Negative y plus 7y, keep in mind this is like a 1, is 6y equals 30 plus 6, 36. Then we solve for y, so I'm going to divide by 6. Y equals 6. Then I have to take that and substitute it back in. You can put it back into the black one, you can put it back into the red one. It doesn't matter. I'm going to choose to go back up here, which is going to give me 3x minus y, which we said was 6, equals 30. Add 6. So 3x equals 36. Divide by 3. X equals 12. And then final answer, write it as an ordered pair. 12, 6 is the point on the graph where those two equations intersect.